So like I stated in the previous video, I'm not going to ask you to memorize or anything the Graham's law here. This will be given. But basically what I want you to learn is that the heavier the molecule, the slower it will go. So the lighter gases always has a faster rate of speed. On your worksheet, you'll see that I think this is the last question, asks you to rank and put into order from fastest to slowest molecule. You don't have to calculate really anything except for the molecular mass. So go ahead and calculate that. And remember that the lighter gas always has a faster rate of speed. And so I will make visible the answers to the worksheet. These are the questions on here. If there's any other problems you want me to know, want me to do, let me know. The last topic we're going to briefly cover, and we kind of already mentioned this, is that real gases exist, and they don't conform to these ideal scenarios all the time. We see that at low pressures and temperatures, ideal gases behave fairly well, but as you increase the pressure a little too much, higher than room pressure, so higher than 1 atmosphere, you can see a deviation from ideal in several cases. And if you go up to even higher and higher pressures, you see very non-ideal scenarios. And when we talk about non-ideal, we mean real gases, where either you have large gases that take up a lot of space and you can't ignore the volume. But most of the cases we're talking about the attractive forces. And so what we'll learn about in Chapter 11, starting on Wednesday, is that molecules can have an interaction between the two molecules, not just chemical bonds like covalent or ionic, but molecules can interact. So if we take the water molecule, right, we have some lone pairs. Those have covalent bonds between the oxygen and hydrogen. But if you put another water nearby, these molecules can interact and share some of the electron density that we talked about in Chapter 6 and 7, and a little bit in 8 and 9. And so then we get interactions between molecules, and that's the main focus in Chapter 11. But this time, or in the next chapter, we'll be dealing with liquids. So that finishes Chapter 10. So like I said, if you have any additional questions you want me or Hannah to cover, please let us know. The best way to do that is I posted an online assessment on the As You Learn page that I'm going to show you now. So if you go to the As You Learn page and scroll down, you will see the Chapter 10 material. Okay, I will update the worksheet answers with the entire worksheet in a moment. And on the very bottom, you'll see Chapter 10 assessment. Chapter 10 assessment, if you open it up, is an anonymous assessment to let me know how you're doing in topics that and questions you have. Again, if you have any additional questions or comments that you don't feel comfortable asking in class, go ahead and submit one of these assessments. I and Hannah have access to them, and we use them to try to build better lead tutoring, and if necessary, I can post additional work problems online and resources if there's enough of a need. But the idea is the more people that respond, the better idea I have about your understanding the material before an exam happens. So if you let me know as we go along, and again, you can take this as many times as you want, it gives me a better idea of materials to cover or review for Hannah also. So that's all the material from chapter 10. Please let me know if you have any questions. And get out of this. And I can't get out of my video.